Dang it. What we have to do at this point is we're getting ready to install the camshaft and the tappets. Now, what has to be done prior to that is we need to determine what shim we're going to use in each one of these locations. And it's all going to be different because each one of these valves and seats has been ground different amounts. So they're all sticking up different distances above the cylinder head before we installed the springs and the retainers and the keepers. So now what you could do is just really, when you take the engine apart, you could just keep track of which shim goes with which valve, and just put them back in as a preliminary measure to then once you get the cam bolted in, then you can take your feeler gauges and find out whether you're on or not, which you're not going to be if you ground the valves. Now, I'm testing a theory this trip that if you've got a specific valve stem height or the distance that the valve is sticking up from the cylinder head, and you're going to need one of these, a valve stem height gauge, in order to determine that, being that all these cam boxes and all these cams should be easily within 1/1000th of an inch of each other as far as dimensions are concerned, assuming that you don't have any abnormal wear, we should be able to develop a chart that tells us what shim should get us pretty close for any given valve stem height. So what I've done is put together a chart, which I'm not going to show you yet until I know that it works. And I've determined what shims I need for these different locations. Now in this one right here, I'm going to need a 99 thousandths of an inch thick. Now you notice that right here I've got my little box o' shims. And you'll notice that on the front here I have the different dimensions for the letter size. Shim A is 85 thousandths. Shim 101 is, or I'm sorry, shim Z is 110 thousandths. And then I've got these little compartments broken up. If you shoot from this side over here, you can see A through Z. And I've got a little spot for miscellaneous ones as well that don't fit anywhere. So what I've determined is that for the exhaust valve on A1, I need a 99 thousandth shim. And just for giggles, because believe it or not, my organization systems do break down occasionally, I will measure it, and I can see that that is 98.5 thousandths. So I'm calling that close enough. So I'm going to put a little assembly lube in there, and you can see that little pocket where the shim fits in. And there you go. Now this is an important point right here. If you've had your cylinder heads done by another party and you haven't gone through them, some of the issues that these cylinder heads can have that we showed you during the cylinder head tech video, at this point what you really need to do is you need to come over here, and as long as you can rock that shim on the end of the valve, you at least know that you've got enough valve stem sitting up. If they ground the end of the valve stem to gain clearance, there's a possibility that you may not actually even be able to rock this shim, which means that instead of pushing on the valve stem, it's pushing on the retainer, and every time that cam comes down, that whole assembly is going to chatter and it will fail. So this is sort of your last chance to check and see that you've got an adequate amount of valve stem on the end. Okay, so as you see, we've got the shims installed all the way down here, and they all look good. At this point, what we're going to do is install the camshaft. And what I'm going to do is I'm going to take a little assembly lube and put it in each one of these bearing saddles. Now what I use is Cleveite because it is super sticky, and it just gives me the, well, a couple of high-level engine builders I know use this stuff, and it just seems super sticky, and it seems like it's going to hang in there for the first few seconds that the engine is attempting to start. Okay, so we got that in there, and what we're going to do now is install the followers, or the tappets. Now these are the shims that originally came in it. I'm just going to take them out and drop them there. What I'm going to do here, when I install these, and I'm not going to show you the whole process, give them one final spritz of air to make sure that all the dirt's off them, and then take my assembly lube and do three things. First of all, put it around the outside where it's going to be riding in the bore. Put a little on the top to lube the cam as it's rotating around. And also put a little bit on the shim. And then take this tappet and set it down in like that. And I like to, yeah, yep, that's good. There's no foreign material or nicks or anything. So that cylinder is ready to go. What I'm going to do now is go down the line and do the rest of them, and we'll have you check back when I'm putting the cam in. At this point, we've got all the tappets installed with the shims in between the tappet and the end of the valve stem. This is an important step right now. You kind of take your finger, and it should be, the tappet should be pretty much flush or a little bit below the cam box at this point. So just kind of run along here and double check to make sure they're all like that. And you know what? Right here, we got a little bit of a problem. This one's sticking up a bit. Imagine that. Okay, that's because somehow the shim got off center. It fell out of that little pocket there. So what we need to do is to set that in place there. And you can see now that we are a little bit below the cam box. All right, so at this point, we've added our assembly lube to the bearings. And what we're going to do now is install our camshaft. And being that we got all that, oh, one thing I forgot to do, you want to install a lube on both sides of there because it rides on both sides of that first bearing. You don't want to gall that. So, and by virtue of the fact you've got all that lube in the bearing saddles, we can just set this thing in. Now what we're going to do is rotate it around so that we've got it as close as possible right here to the bearings. Now the reason it doesn't fit down, of course, is that you've got some valves that are supposed to be open at this point. So what we're going to do is we're going to install our bearing saddles. And what that's going to involve is shooting a little assembly lube into the bearing saddle and on the faces. Now this first one is the one that takes the thrust loads of the camshaft, keeps it from moving back and forth. Another thing is that the number 1 here, if you can see that goes on the down side. You can see right here you've got these holes that the water rails fit into. Those are on the bottom of the head. So the numbers go to the bottom. And just take your time. And because they fit so close, you have to kind of pick the camshaft up a little bit. And there you go. That's the first one. second one, and so forth. Okay, so what we're going to do now is just rotate the camshaft around to see if we can get the maximum amount of thread showing on these bolts in the middle. Number 4 bearing saddle. And there we are, okay? You can see we got a couple of threads showing. We're going to put a couple of washers on there. And we're going to take and put a little lube on the nuts that go on, and there's only going to be maybe one thread that's catching there. And the same thing on the other side. Okay. Now, we're going to carefully tighten these because we just barely have a hold on the end of that. Now, what we're not going to do at this point is just keep tightening this one down and putting all that stress on this camshaft generated by the springs and the valves. It probably doesn't hurt anything to do that, but it just seems to me that it's not a good idea to torture parts into position. So what we've got here is we've got the front end, we've got plenty of bolts showing here. Back end, not so much. So I'm going to tighten this down to the point where I can do the same thing with those two bolts back there. Everything's getting kind of sticky and slippery at this point, so I'm hoping I don't drop anything into the head here. Not that that's a big deal at this point. Oops. A little bit too much on this side. Okay. Now these will loosen up as we go along, but that's not a big deal at this point. Not a big concern. I got that one. I put 2 washers on there. Not a good idea. We'll cut that out in the edit. Okay, so now we can get the last ones on the end here. Okay, at this point, now don't tighten one side down and then the other. Go down in stages, because if you If you go down all the way on one side, it'll tend to take the saddle and bend it like that. And I don't know if you could actually bend the stud, but, and you can come over here and you can tighten this one up. And at this point, you can go ahead and put the nuts on here, which would be real easy to do. And you can tighten everything up. These, according to the Haynes manual, go to 10 foot-pounds of torque. So at this point, I want to slow down and make sure everything is right here. And we'll come back later when we are going to discuss how to check the valve tappet to camshaft clearance. Okay. Next step that you need to do is to make a chart like this, or a form to record your results. Now, you can see that we've got cylinders 1 through 6, and we go exhaust, intake, exhaust, intake, exhaust, intake on the first 3, and then intake, exhaust, intake, exhaust, intake, exhaust on the last 3. And that's because that's the way the valves are situated on the cylinder head. I drove myself nuts going intake, exhaust all the way down, and then couldn't figure out why my results were changing. I finally did it 4 or 5 times before I finally figured it out. That was a while ago. Now you can see that what we've done here is, once I got this set up over here, what I did then is recorded the shims. Now remember I said that I've got a theory that for a specific valve stem height, there should be a specific shim. So that's what I did here. I installed a 0.099, 0.104 in cylinder number 1, and then recorded all that information. Then what I did is I came over here to the cylinder head, and I'm going to do cylinder 5 and cylinder 6, the intake on cylinder 5 and the exhaust on cylinder 6, because that's the last one I ended up with here. What you do is, first of all, start out with 12, which is as small as it goes, as the tolerance goes. It should be between 12 and 14 thousandths. Okay, nothing. That felt like it was pretty tight, so I'm going to go to 10. Oop, 10 goes in. Okay, 10 goes in. A little tight, but it goes in. So I come over here. That was intake on 5. You can say I recorded 0.010, 10 thousandths of an inch. Then exhaust on number 6. Tried 10 again, no go. Felt really, really tight. So let's try 8. Nope. Try 7, if I can find it here. There we go. 7, and 7 goes in, 0.007. That went pretty easy, so I'm going to try 8 again. You look at our little table here, you can see that all of the clearances are much smaller, except for 5 and 6 on the intake side, than what my theory would have projected. So there's some holes in it, and I don't know that our results would have been any better than if we'd have just taken the stock shims and stuck them back in and used those for preliminary adjustments. So what we do at this point is we take the minimum clearance that we want 0.012, subtract the clearance that we found, which is 2 thousandths, and we come up with plus 0.010. Now what that means is, now variation is the word that I'm using here. Not sure if that's the correct mathematical term, but we're going to go with that. What this means is that if my clearance is 2 thousandths of an inch, which is way too small, my shim is 10 thousandths of an inch too big. So what I'm going to do is I'm going to go to my little box of shims here, and I'm going to find a shim that is 10 thousandths of an inch smaller than 0.099. And that would, of course, be 0.089. And then I'm going to go down the line and figure out what the new shims ought to be. At that point, I should just be able to find those shims, remove the camshaft, remove the tappets, and then install this row of new shims, and it should be really close to 12 thousandths of an inch. If you want to be sure that you hit the range here, you could go to 13 thousandths, which means that it would be 1 thousandth of an inch, and this would be 0.088. And, you know, work it that way if you wish. So, now you might be asking yourself the question, what do I do if I need a particular shim and I don't have it? Like, for example, if we're looking at my little box of shims here, you can see they got tons of SRQPs, but as we go down the line here, there's several spaces where we only got 2, 3, and there's a few spots where we don't have any. Well, you've got options. First of all, if you're down at this end of the scale here, maybe even smaller than an A, you're going to have to have some shims shaved or ground. Now, there's a pretty easy way to do that. Most machine shops will have something called a surface grinder. And if you need to take one of your thicker shims and have it ground down 3 or 4 thousandths, that's really the way to do it. What a surface grinder is a magnetic table that you put your shims on, they throw a lever and it activates the magnet and it holds onto it, and then you can move the table back and forth or the grinding head back and forth. It's a wheel that's oriented this way vertically, and you just pass it over the shims and it takes however much off you want, just little bits at a time, of course. You don't want to go too fast. These are hardened, and you don't want to heat them up to the point where you anneal them, which a machine shop isn't going to do that. So that's the way to do it. Take the shims that you want into the machine shop, tell them what you want done on each one of them, and they'll probably have it for you in a couple of days. The problem arises when you're working on your engine, and the fact is you're working on your engine after work and on weekends, and these are times when your machine shop friend really doesn't care about you and the fact that you need him. He's home working on his own life, okay? So you've got to figure out some way of doing it yourself. Now, if you got to take a lot off, that's going to be a problem. But if you only need to take, for example, you need a G and you've got an H, well, that means you only need to take about 1/1000th of an inch off. There's a couple of easy ways to do that, and it's really pretty low cost. You can use either a stone here or a piece of material with some wet or dry sandpaper contact cemented to it. Now what I've got here is a little sort of a holder for the shim. It's just a piece of aluminum that has a little cavity machined into it. And what I'm going to do here, first of all, let's clean this up because there's some crud on it. First thing you do is you put a little dot of oil in the middle like this and put your shim in. Now you'll notice that most of these shims, it's obvious which side has been down. You can see that there's a little circle in the middle. That's where the end of the valve has been tapping. And the fact is, that's probably about a 1/2 of an inch thinner at that point than it is outside of it. So what I do is I make sure that that circle is down. That's what I'm going to be grinding on. Now, what I've got here is just a stone that I've taken over to my belt sander, and I do this occasionally with it. Sand it flat. Belt doesn't like it much, but you got to do what you got to do. And then we take some oil and spread it around. And then because we got the oil under the shim, we can put it upside down like this. And we know that in order to remove that circle in the middle, we've got to go a 1/2 of an inch. And keep moving the shim over the entire surface of the stone so you can keep it as flat as possible. Because you want to keep the shim, the two surfaces of the shim, parallel to each other. Because if they're not, the shim is only going to be making contact at one point, and that might be hard on not only the shim but the tappet as well. So we do this for a while, and there we go. Pretty interesting. At this point, you can see that that's almost gone. And there's another good point. I don't know if you can see that it's actually a little, let me wipe some more of this crud off of here for clarity's sake. You can see that it's in kind of a half moon shape right now. You can see that it's been worn more on one side than on the other. Okay? That's a good thing, because you can use that to determine whether you've gotten that surface, or that surface is still parallel to the other side or not. So you got an indication of where you need to be grinding. So that would be, I would need to apply just a little bit more pressure on the back side of this than on the front. So we can keep doing that. Again, being mindful of where the shim is on the stone, try to keep it as uniformly worn as possible. There, that's better. Again, I don't know if you can see that or not, but when you get that out of there, when it's perfectly flat all the way across, you know that you've removed a 1/2,000. You've got another 1/2,000 to go. Now this other one here, I use if I've only got maybe a 1/2,000 or 1,000th or less to do. Again, this is a piece of 320 grit wet or dry sandpaper that has been contact cemented on here. A little bit of oil on the surface, and essentially the same principle. You want to keep moving it all over the place so that you're not wearing it all out of all the grit off of one spot. And yeah, that's all gone at this point. And what we want to do, now when I say it's all gone, I'm talking about that circle that was in the middle. And then what you do is you take your dial caliper, make sure that it's zeroed. And 94.5, 94.5, 94, 94.5, 94.5, 95.5. Now when it's 1,000th off, it's probably because there's some crap that got in between there. 4, 5, 4, 5, 4, 5. So we know that it's parallel all the way around. Now, if I wanted to go all the way down to 94, what I would do, now that I've got that circle out of there, I just simply flip it over, put the good side up, and then do it all again, get the other 1/2 thousandth, and so forth. Easy. Takes a little time. It could take you maybe a 1/2 hour to remove a 1/1000th of an inch. But again, after hours on a weekend, this is the way you can keep going instead of waiting for the machine shop to open up on Monday. We are one camshaft removal and shim replacement away from this cylinder head being ready to go on the engine. So it's up to you whether you want to put the studs in now, also the water rails, or just wait until you get these on the engine. Makes them lighter, easier to handle, and less probable that you're going to damage yourself on these cylinder head studs. So there you have it. How to rebuild Jaguar V12 cylinder heads. Glad I could help. It's part of the project. It's officially over. What are you looking at?